This video is the solution video for Part B of the 2019 Physics Regents exam. Alright, so B1 goes 36 to 50, multiple choice, let's go. So to start strong with 36 with a proportional change question involving universal law of gravitation. And I know this is a proportional change and not a plug-in question because we're doubling, there are multiples here, we're doubling mass. This is not like here's one planet, here's another planet, here's the distance between them, solve for the force. It's proportional change. So we have a mass 2m that's in orbit around the moon. And then the second mass is, of course, the moon, so that hasn't changed. But then the separation, it says it's 1 moon radius from the surface of the moon. So you can see that here, that it's 1 lunar radius, 1 moon radius. But it already started off like this mass, this guy right here, that's 1 moon radius to begin with. And then this mass of 2m is another moon radius. So it's like 1 more radius. So we're actually doubling the separation. So separation is doubled. And so with double the mass of the object, same mass for the moon, and double the separation away, we get that it's 2 over 2 squared, so that's 2 quarters, or 1/2 the force. So if the original force was F, the original is with the gravitational force F. If the original force is F, half of F would be choice 3, F over 2. Okay, we have a velocity versus time graph. I know that the slope of a v versus t graph is equal to the acceleration, and then the area under is equal to how far it goes. And so it asks, graph below represents relationships between velocity and time. What is the acceleration, which we just said? It is the slope. I can also see that the slope here is constant, so I can really take any 2 points on this straight line to get the slope. And so when I take the slope of that line, I get 10 meters per second squared, and that's choice 3. Okay, so 2 muons. Muons are, if you look on page 3 of the reference table, a muon is a type of lepton, and its charge is -1 elementary charge. It said there are 2 muons, so there would be -2 elementary charges, but the question is asking in coulombs, so we have to convert. So there are 1.6 times 10 to the -19 coulombs for every elementary charge, and so if there are 2 of them, then it would be 3.2 times 10 to the -19 coulombs. Negative because the muons are negatively charged particles. All right, muon is like a cousin to the electron. Okay, 39. So we have a 1.47 Newton baseball dropped from 10 meters up, and it says when it reaches the ground, the kinetic energy is 12 joules. So what should happen here is that the kinetic energy that it gains as the ball falls is the gravitational potential energy that it's losing. But it's asking about the internal energy, so there's going to be some internal energy loss there. Well, let's figure out what the actual gravitational potential energy is. So gravitational potential energy is mgh, and we already have mg in the form of the weight. So we don't have to go and get the mass and multiply by 9.81. We already have the weight, the 1.47 newtons, that is equal to mg. So we have that mg. We'll slip into 1.47 multiplied times 10. And so the change in gravitational potential energy is 14.7 joules. And so the kinetic energy is at 12 joules of kinetic energy when it has reached the ground, and it had 14.7 joules, 0.7 joules of potential energy up when it was 10 meters up. I did the same thing twice, 14.7 joules. And then the heat, the internal energy, is the difference between them, which would be 2.7 joules. And so the amount of energy, it says the mechanical energy converted to internal energy lost to heat is going to be 2.7 joules, choice 1. Now, a couple things here. Mechanical energy, that's energy of motion, that's kinetic energy, gravitational potential energy, and then internal energy is Q, which is heat, just so you know your vocab there. All right, so that is 39. All right, we have projectile angles, and it wants the greatest horizontal displacement, and wants the greatest range. So we don't want time in the air. We need y velocity, but we don't need to maximize the y velocity. We actually want to optimize the forward velocity and the upward velocity. So I want 45 degrees for my angle. And so, all right, 45 degrees, great. Choice one. Wait a second, not choice one. I was like, well, why not? It's 45 degrees. Yeah, but check it out. You want not just 45 degrees, but you also want a faster speed, right? If you throw faster with a faster initial velocity, that'll increase your time in the air and your range. So yeah, I went 45 degrees with a faster speed. That is going to send it the farthest. So 40 is choice 3. Okay. 41, things that I know. All right, so we have two forces acting here. We have the pushing force going to the east and the friction force to the west, and it wants to know the acceleration of this box. Well, we know that A is F net over m, but we need to get the net force. And don't forget that backup equation for friction, because I can't do FF as mu Fn, that's not going to help me. But I do know that net is push minus friction, and I know push and friction. Now, the pushing force is greater than the friction, so that net force is still positive, and so this box is going to speed up even though there is friction. And there it is, the acceleration is 2 meters per second squared, choice 2. Okay, 42 is a circle question, and it wants to know at the instant shown in the diagram, which way is the centripetal force acting? Or not just which way, but how much is it? So when we write down our mass velocity and radius, centripetal force is mv squared over r. That's the combination of Fc equals mac and AC equals v squared over r. Don't forget to square the speed. We get 9 newtons. So 4.5 is out. And then I know that centripetal force always points inwards towards the center of the circle. And so in that case, inwards going to the left is going to the west. So it's 9 newtons west, choice 4. Okay, so we have different circuits here. We have a parallel circuit, and we have 3 series circuits. And so I know that in parallel, all the voltages are the same. And it says, in which electric circuit would the voltmeter read 10 volts? 10. This says 20 volts, and so this would also be 20 volts, and so it's not 20 volts, and so it's not choice 1. Okay. In choice 2, I have a voltmeter across the entire circuit, so really this voltmeter is actually across the battery, and that battery is 20 volts, and so that voltmeter is also going to read 20 volts, and so that's not it. All right. And then I have another series circuit, so I have 10 volts, but the voltmeter is across only one of the resistors. And in series, voltage is shared, so each one of those resistors would be 5 volts and 5 volts because they're identical, they're both 1 ohm. They add up to 10, but it said I want my voltmeter to read 10 volts, so voltmeter is going to read 5 volts in this case, and it's not that, and so that leaves me with choice 4, because that voltmeter, like in choice 2, is right across measuring total voltage, but the total voltage in this case is 10 volts. So 43 is 4. Okay, we have a baryon called lambda. It has the Planck composition UDS. It says, which particle has the same electric charge as that baryon? Well, let's figure out what UDS is. So UDS is up-down strange, and if we refer to page 3 of the ref tabs, and so if we combine plus 2/3 E and 2 negative 1/3 E quarks, I get neutral, I get 0. And see, which particle has the same electric charge as the lambda baryon? Well, which one is also 0? So definitely not the electron, not the proton, and then the muon is negative 1 E, and so the anti-muon is positive 1 E, so it's not the anti-muon, it would be the neutron, because neutrons are neutral. All right, 45. So we have 24 megajoules of energy. Let's remember that mega means a million. And that fact, the Prefixes for powers of 10 is on page 1 of the ref tabs. So that's my energy, and I want to know how many kilograms of matter that would be. So I'm going to do E equals mc squared. And so we squared the 3 times 10 to the 8 meters per second, and we divide both sides by that to give us a mass of 2.67 times 10 to the negative 10 kilograms, and that is choice 2. Okay, so we have red photon in hydrogen has an energy of 3.2 times 10 to the negative 19 joules. Which energy level transition does an electron in hydrogen undergo to produce this photon? So it's a photon. To produce this photon, the electron has to be falling. So we're emitting the light. It's going from a higher level to a lower level. So all of these are falling. Great. And actually, if you remember, when we looked at hydrogen, what colors the transitions were, it was actually 3 to 2. When they said red photon, that kind of gave it away. 3 to 2 produces that red line in hydrogen, so it's choice 1. But there is actually a way to figure this out. We need the chart on page 3 of the ref tabs, but the energy here is in joules. We're going to need to be in electron volts, so we convert. So it's 1.89 EVs, and so we really have to take a look at which transition, 6 to 2, 5 to 2, 4 to 2, or 3 to 2, gives you 1.89 EVs. All right, so yeah, it's a little tedious, but I ran through all the transitions, 6 to 2, 5 to 2, 4 to 2, 3 to 2, and got all of the different photon energies, and we figured out that the 3.02 times 10 to the negative 19 joules is 1.89 EVs, and so that transition would be from 3 to 2. So if you didn't know that red for hydrogen was 3 to 2, that's actually how you would calculate it. Kind of annoying. All right, so let's move on to number 47, and this is the last page with multiple choice on it. And so we have 2 spheres, and there's a negative rod in the middle, and it said negatively charged rod is placed between but does not touch identical small metal spheres R and S hang from insulating threads. And then I can see that R is tilting away, so there's a repelling force on R. And so if the rod is negative and R is repelled, R must be negative. So 3 and 4 are out. And then it says sphere S must be positive. I mean, if S was positive, it would be attracted, but let's remember that charged objects attract neutral objects. And so sphere may be positive because opposites attract, or it may be neutral because charged objects attract neutral objects. And so 47 is choice 2. Okay, 3 more in the multiple choice. We have power, 60-watt light bulb, that is the power. The time is 1 minute, but we need that in seconds, so that's 60 seconds. Could lift a 10 Newton object, and that's the F, that's the force, to a maximum vertical height of, so that's the D, and it wants to know what is D. So we do, and when we work the numbers, 60 times 60 is 3,600, divided by 10 is 360 meters. That is pretty high. Choice 3. 49. Interesting question. Microwaves can have a wavelength closest to. Well, first we need the wavelength of microwaves. So you need to check the electromagnetic spectrum chart on page 2 of the reference tables, and the microwaves range from 10 to the negative 4 meters all the way up to 1 meter. 10 to the negative 4 meters, that is less than a millimeter. And so it's about, hold on, 0.1 millimeters. 0.1 millimeters all the way up to a meter. Now, where would that be close to? Would that be close to the radius of the Earth? Heck no. Would it be close to the height of Mount Everest? Def not. Would it be close to a football field? We're getting closer, but no. Or the length of a thumb? Yes. So that's choice 4. Interesting question. All right. And then 50 has these 2 shapes, and I remember talking about this with one of you guys, just trying to noodle what would these 2 shapes look like if they were on top of each other. And they don't exactly cancel, and they don't exactly reinforce. So if you visualize it, I know that it's kind of like the crest is going to the upper, is kind of tilting to the upper right. That's the crest, and then the trough is kind of tilting downwards into the lower left. And so the pattern that really makes the most sense there is choice 1. There's your trough and there's your crest, kind of like reinforcing each other. I don't really like that question. I don't like the shape they chose. And so anyway, 50 is 1. Okay, so that was B1 multiple choice. Now it's time to move on to the B2 constructed response. And yeah. So 51 through 53 talk about a toy launcher used to launch small plastic spheres horizontally, so like a pop gun, has a spring with a spring constant of 50 newtons per meter, and then the spring inside is stretched 0.1 meters in order to launch the sphere. So it wants to know what's the elastic potential energy. So that's elastic potential energy, that is spring potential energy. And so if we do 1/2 kx squared, we don't forget to square the x, we get 0.25 joules for our energy. And then 5253 wants to know how fast would the ball be when you shoot it. Spring potential energy becomes kinetic energy. And they also give us the mass of 0.1 kilograms. So we put in the energy, spring potential energy. They always have error carried forward there in case you got 51 wrong. And then you put in the mass, and we're going to solve for the speed. Don't forget that speed is squared, so you'll have to square root. And so the speed of the ball winds up being 2.2 meters per second. All right, next question, 54. 54 is draw a circuit with 2 resistors. It says the 2 resistors have an equivalent resistance of 5 ohms. If these resistors were connected in series, they would add up to 20 ohms. They do not. They add up to 5 ohms. It is not a series circuit. So yeah, based on the parallel equation, the two 10 ohm resistors must be in parallel to have an equivalent resistance of 5 ohms. All right, so now that we've established it's a parallel circuit, it says draw the circuit. There are no meters involved, so I don't need the meters. Power supply, resistor 1, resistor 2. That's it. 55, graph of distance versus time with a steady slope. And then I know the slope of a d versus t is velocity. And it says, on the axes in your answer booklet, sketch a general shape of the graph that shows the relationship between the magnitude of velocity and time for the moving object. And so I know that the slope, here's the key, the slope is the velocity, and this slope, that is a constant positive slope, so therefore my v versus t graph would be positive and constant. All right, so 56, 7, 8 looks like a refraction diagram. Ray of monochromatic light, there's the reference frequency for the indices of refraction, 5.09 times 10 to the 14 hertz, passes from medium x into air. Angle of incidence in medium x is 25 degrees as shown. So it's going from x going into air. And it says using a protractor, measure the angle of refraction. That would be theta 2. So it wants to know what is that angle. I measured that angle and we got 40 degrees, plus or minus 2 degrees. And then 5758 says, what is the index of medium x? And so using Snell's law, we get 1.5 for medium x. Don't forget to be in degree mode. And for sine, cosine, or tangent, it matters. Also, do not miss writing the degree symbol down. That counts as units. If it's missing, you're going to lose the units point. Okay, we're down to the last part of B2. And so we have 5960. Okay, 5960 is a free fall problem. We know the mass of the watermelon and that it falls from rest, so V initial is 0. Then 29 meters per second when it reaches the ground. I made that negative because it's falling downwards. Also, since we're freely falling, my acceleration is due to gravity, and it's negative 9.81 meters per second squared. And it wants to know how far it needs to fall. So it wants to know what is d. All right, so I don't have the time. I don't need it. So we do Vs squared plus 2AD. And again, Vf, it says, is 29 meters per second. That's before the ground has slowed it down. And so we solve for D, and it does come out as negative because the watermelon does displace downwards. But so it would have fall through 43 meters. And that is the answer to 5960. All right, 6162, we have ourselves a collision. So it says we have block A with a mass of 100 grams going 4 meters per second, hits block B, which is at rest. And then afterwards, block A rebounds, bounces off of B, heads to the left. And then block B, it says moves, which it must be to the right. And it says calculate the speed of block B after the collision. So they don't stick together, so this is going to be an elastic collision. And I'm just going to derive the collision equation because it's not on the reference table, so I want you to understand like where it's coming from. So what is on the reference table is that total momentum before equals total momentum after. We have two blocks, so we have A and B, so the total momentum of A and B before equals the total momentum of A and B after. And then we know that P equals mv, so we have the mass of A times the velocity of A before plus the mass of B times the velocity of B before equals the mass of A times the velocity of A after, I'll use prime for that, plus the mass of B times the velocity of B after. Now the masses are in grams, but they're going to be in grams all over the place, so I don't really see the need to convert to kilograms. All right, so then the velocity of B, all right, and so the B was at rest to start, so that's 0 meters per second. And then A rebounds, so that's why I put negative 1.5 meters per second there. So let's collect our numbers. We have 100 times 4. So then, 100 times 4 is 400. 100 times negative 1.5 is negative 150. And so let's collect terms and solve for the velocity of B after. And so when we work the numbers, we get a velocity of B of 3.7 meters per second, speed of block B after the collision. This is going to get real small, so I'll rewrite it here. 3.7 meters per second. Okay, and then the last questions in part B are the set 63 through 65, and it's about more momentum. It's about impulse. So here's the given information. We know the mass of the car, its initial velocity comes to a stop, spread comes to rest, so V final is 0, and the time is 5 seconds. And then 63, 64, when's the impulse? So impulse is a few things. It's change in momentum, it's net force times time, but it is also equal to m delta v, and that is the part that is not on the reference tables. And that's the version we're going to need. So yeah, the impulse winds up being 30,000 kilogram meters per second. It says the car was traveling east, so the negative there makes it west. But it just says magnitude of the impulse, so we don't actually need the west. We just need the 30,000. And actually 65 does want to know what the direction is. And so if it's negative east, the direction, like I said, was west. And so west because it was traveling east, but the answer is negative, so negative east is west. And that is the end of the B2s, and that is the end of the Part B video.